And then it's somewhere here. And here is VR2. Okay, and then here, madam labelkan apa dia tu? EA ya? Ada tak? Saya label ke tak?
Ada EA.
Okay, EA. Okay, and then here is RA. And this is the inductance. And okay, current dah ada kat bawah ni. This is current. Okay. And then, so you have to listkan the subsystem from this mature control DC motor is used to drive inertia. Okay, this is our inertia, meaning to drive the inertia where the output is angular displacement. So meaning the output here ada torque and ada angular displacement. Okay. The circuit receive voltage supply from the output of amplifier. Okay, so maksudnya EA is the output from where? EA is the output from amplifier. Okay. So input kepada what? Input to the amplifier. What is the input to amplifier? What input to amplifier?
VR2.
Yes, good. We are 2. So meanings from there, let's say we derive the first system. What is our first system? First system is our potentiometer. Our potentiometer is our first subsystem. The second subsystem is our amplifier. Okay. The third subsystem is a mature circuit. Okay. Fourth, you have to define the equation or the transfer function for the motor. Okay, the last one. What is the last one? What is the last one? What is subsystem for the last one?
Rotational.
Yes, good. Rotational mechanical system. Okay, we have a 5 subsystem here. Okay, from this electromechanical system, we can divide into 5 subsystem, and then from number 1, from system number 1, potentiometer, you have to derive what equation related to the potentiometer. So meaning from number 1, okay, number 1 is a potentiometer. So potentiometer, we use what? VDR kan? We use voltage divider rules to define what's the output. Meaning we want to define the output from the potentiometer. So meaning the output is VR2 equal R2 over R1 plus R2, and then you have to multiply with the input. Okay, you have to multiply with the input. Okay, and then from here, so you have to identify which one your input and which one is your output. So you have to rearrange the equation based on what? Based on output equal to gain multiply with the input, right? Okay, so is it this equation fulfill this requirement or not? Dia dah follow ke tidak? Kita punya,
Yes.
okay. So meaning VR2 is your output from the potentiometer system. Okay, so meaning from here you draw your block diagram. You draw your functional block diagram belong to subsystem number 1, belong to potentiometer. So meaning the input is a VI, okay, the output is a VR2, and then here is a R2 and R1 plus R2. Okay, so we complete our subsystem number 1. Okay, and next we have to go through subsystem number 2, amplifier. So amplifier, what's the input amplifier? VR2. What's the output? EA. So number 2, output from the amplifier is EA equal S equal to amplifier dia that's given K for the constant for what constant gain for amplifier, and then you have to multiply with the VR2. Okay, this is the equation for amplifier. So meaning the block diagram is which one the output for amplifier? Which one the input for the amplifier? This is the gain. Which one the output or input? VR2 from here. The
VR2
meaning,
input.
yeah. So this is we get the VR2 and this is the EA. Okay, we complete for amplifier. Okay, the third one, armature. So you have to derive the armature circuit. Okay, the armature circuit we use Kirchhoff rule. So jadi apa equation armature kita? So our EA equal to okay, around the armature. So meaning the VRA plus LA plus VB, right? Okay, from here you have to rearrange or you have to simplify. You have to based on the relationship voltage impedance. Okay, so meaning this one is RA plus with the what's the impedance for inductor? LS, right? LAS, and this is you multiply with the current, and then you have to plus with the back EMF. Okay, right. So from here, so we simplify voltage with the voltage VB equal to RA LAS, and this is the current. Okay, so from here, which one input and which one is the output for a mature circuit? Which one is the input for the amateur circuit? What's the input for this one?
EA
Okay,
minus VB.
okay, this is the input and this is the output for that subsystem. Okay, so you have to rearrange. You have to rearrange that equation. So make it IA output equal to, this is the gain, RA plus LAS, and you multiply with the input. Input is combination of applied voltage minus with the back EMF. Okay, and then from here, you draw the functional block diagram for this system. And this is the current. And what's this? This is your LS. And this is what? This is your EA and minus. And this is your VB. Okay, so we settle our armature circuit, and then the next one you have to derive your DC motor. So DC motor, how many equation you can derive from the DC motor? Number 4, DC motor. How many equation you can derive from the DC motor? Ada berapa equation you derive dekat DC motor? How many equation? One is for back EMF. Okay, for back EMF, satu equation. Another one is a torque. Okay, so apa equation yang you can derive? What equation you can derive from here? What relationship between back and the speed? What relationship between back, this one, back EMF? VB proportional with the d theta over dt, meaning BMF is proportional to the speed. Okay, so we taking Laplace transform. So apa yang kita akan dapat this one? So we can get equal to, we come up with the one coefficient, meaning we make it KB, and d theta over dt, Laplace transform, kita akan dapat this one. Okay, so number 2, torque proportional with I armature. Okay, I armature. So from there, we simplify the equation, we can get coefficient for motor, and this is our current. In term of S domain, right? Okay, so habis dah. Ada last sekali apa? Rotational mechanical system kan? Okay, apa dia punya passive element yang diberi kat situ? Inertia, spring and damper. Inertia, spring and damper. Number 5 is a rotary mechanical system. So meaning impedance for inertia, J squared, plus damper, plus spring. Multiply, you all kena, you multiply with the motion. You multiply with the angular displacement. Okay, equal to total of torque. Okay, so you have to rearrange this question to get output equal to gain multiply with the input. So torque is our input or output? Torque. Torque is applied voltage, applied torque into the rotational mechanical system. So meaning torque is your input. Yes, good. So from there, you know theta equal to Js squared plus ds plus k. And then you have to multiply with your input. Okay, from here, you draw the functional block diagram for this system. Okay, the theta is your output, torque is your input, and this one your impedance for that system. Okay, so we have equation and functional block diagram represent for that subsystem. Okay, so daripada situ kita combine. Okay, you have to combine all this one. All the system, you have to get the complete block diagram. Okay, we have to combine. We have to get the complete block diagram or overall block diagram belong to this system. Okay, so macam mana kita nak buat block diagram dia? How to define the block diagram? So which one start? Start dengan mana? Kita start dengan apa sistem kita? We start with
potentiometer.
We start with potentiometer. Mana kita punya potentiometer tadi? Okay, this is our potentiometer. Okay, this one. Okay, this is our potentiometer. So jadi kita start lah dekat sini. Kita copy balik. Okay, ini adalah R2, R1 plus R2, input VIS, and then output dia is a VR2. VR2 akan pergi mana? So the next system, it goes to K, right?
Amplifier.
Yeah, it goes to amplifier, and the output for amplifier is a EA. And then from EA, they goes to where?
Armature.
Yes, they go to armature kan? They goes to here. Betul tak? Dia akan datang sini kan? Okay, so we combine. So we have this one. Okay, minus. This is our VB. Okay, this is a 1 over RA plus LAS, and the output is a current. Okay, so from the current, kita nak cari which block? Which block yang ada current? Mana? Mana? Current tu gimana tadi ya? Alah, madam tak lukis. Supposedly. Dekat sini kan? Dekat sini ada kan? So kat sini ada current kan? Dekat sini ada torque dan dekat sini km. Betul tak?
Betul.
Okay, so untuk yang sini this one kbs. Okay, the input is a theta and then the output is a VB. Okay, so from IA tadi kita pergi dekat sini. Okay, so tak muat lah pula. Macam dia padam Okay. Dia padam ni. So the next dia pergi IA. IA apa tadi? K what? KM kan? So KM output dia torque. Betul tak? Okay, output dia torque.
Betul.
Okay, lepas tu yang ni masuk kepada rotary mechanical system kan? So jadi 1 ds squared plus ds plus k. And then output dia apa? Output dia adalah angular displacement. Angular displacement, macam ni nak combinekan angular displacement dengan VB? How to combine?
KBS.
KBS tadi tu. So kita feedback kan, dan ni adalah KBS. So ni pun theta angular and then akan masuk sini. Betul tak? Okay. So ni daripada sini kan. Ni VB dia feedback and then dia akan merge dekat summing point ni. Okay, kita akan merge dekat sini. So ini adalah block diagram view. This is the overall block diagram represent for that system. So you have to define the transfer function. What is the transfer function yang kita kena define? Transfer function, apa output dia? What's the output for that system? What's the output for that system?
Angular.
Angular. Dekat sini pun dia dah cerita kan? Where the output is angular displacement. Okay, the output is angular displacement. So, first kita boleh buat apa? Ni Madam labelkan A and B. This one, I make it C, D, E. And this one is a F. Okay, so first you boleh cascade A and B. You can cascade A and B, right? Betul tak? You can cascade A and B. This one. So maybe we cascade here. You can get AB. The input is VI. And then it goes to summing point. And then here, what is this inside this block?
CDE.
Okay, good. CDE. And then you have to feedback with F. Okay, this is your output. Okay. So you have to simplify the feedback and after that the gain you cascade with AB. Senang je kan? It's very simple, betul tak? Okay. Then from here you can get A and B cascade. And then from here you will get CDE. This is a minus 1 plus CDE multiply with the F. And then this is the output, angular displacement. Okay. So the last one, you cascade for 2 blocks. Okay, you cascade X and Y. Okay, so from there you can obtain your transfer function is X multiply with the Y. Okay guys. So far so good. How to simplify
Okay.
this block diagram? Okay.
Okay.
Okay, right. So kalau okay, Madam nak bagi tutorial. Sekejap ya. Bagi Madam 2-3 minit. Give me 2-3 minutes. I nak tunjuk apa? Tutorial sekejap. Sekejap ya, I stop presenting. Weh, bunyi apa tadi tu? Apa tu? Ayam siapa tu?
Ayam serama.
Ayam waktu-waktu ni ada yang berkokok eh? Ada yang berkokok ke waktu-waktu ni? Serius?
Ada Madam.
Kan?
Ayam nampak
Okay.
sesuatu tu.
Okay, kita ada 20 orang. Siapa yang tak ada ni? Who's not around? Who's not around? Hands up your hand. Siapa tak datang? Kawan siapa tak ada?
Hakim ada. Hakim.
Hakim tak ada ya? Hakim tak ada. Ada Saleh, ada Syamili, ada Miong. Okay, Hakim tak ada lagi. Kenapa ya Hakim masih tak ada je ni? Okay, Hakim tak ada. Dia ada bagi tahu tak internet problem ke apa-apa ke? Tak ada. Kamak Ashraf ada? Okay, Kamak Ashraf is there. Siapa lagi seorang? Kita ada 22. Seorang lagi tak ada. Siapa tak ada? Maybe gang orang kot. Syah. Who's another one? Syah tolong saya identify. Who's another one, guys or girls is not around?
Kita sepatutnya ada 23 kan, Meda?
22. 14 campur 8. My connection is slow, madam. Justin.
Tapi dia ada.
Dia ada kan? Tapi yang tak ada tu tak tahu siapa.
4, 5, 6, 7, 8. Yang diorang ada cukup 8 orang. Yang tak ada.
Tu kalau cukup mungkin kita lah tak ada. Kita ada 14. Seorang tadi dah tak ada dah yang Din bagi tahu tu. Muhammad Al-Hakim tak ada. So siapa seorang lagi yang tak ada tu?
Macam semua ada je, Meda.
Ya, semua ada
Tapi
21. Kita ada 21. Betul lah 21. Semua ada lah tu. Hakim je lah yang tak adanya. Betul. Medium tu salah tengok atas ni. Total 22 campur medium. Tolak 1. 21. Betul lah. Okay, right. So Hakim je tak ada. Okay, thank you. Medium nak verify. Okay, right. Okay, complete our attendance. So now I want to show you the tutorial. Just example, okay? So let's try this one. Nampak tak? Nampak ke? Di sangat ke? Okay, nampak ke? Set media dah share ke belum? Media dah share kan?
dah nampak.
Okay. Okay, question 1 we finish. Okay, we already discussed for our question 1. Okay, this is the similar how the question looks like. Okay, the microcontroller is used to drive inertia where the output is angular, and then the circuit receive voltage supply from the output amplifier as shown in figure. Okay, and then normally the constant gain is given. Okay, so from this example, whereby KB is a back EMF constant, so you have to use the given constant from the equation. Okay, so you have to use during your derive the equation, and then KB back EMF constant and KM is a motor torque constant. Okay, and then from the system you have to determine the ramp function, angular displacement, output, and VI is your input. Okay, this is we done. Okay, how about equation number 2? Equation this one is quite blur. When I zoom, it's okay. Who can? Oops, sorry. Okay. Who can simplify, or who can give the system here? What system or what subsystem you can see from this circuit? The microcontroller DC motor is used to drive inertia. where the output is angular displacement. Okay. And the circuit receive voltage supply from the output of the field controller DC generator as shown in figure. So meaning V0 is the input to the armature circuit and V0 is output generator. Okay. So meaning the first system is what? What is the first system? What's your input? Input is a VI, is it? Okay, what is the first system? First subsystem you can derive here. Apa sistem pertama yang you boleh derive? What is the first system you can derive? See what? This is question 3. Okay.
Potential meter.
Ha?
Field
Potential meter.
Mana potentiometer? Apa
Physical.
subsystem?
Constant speed apa tu?
Physical.
Field circuit. Field
Oh,
circuit dekat
field.
situ. Betul tak? Field circuit kan mula-mula ni adalah field circuit. Betul tak? Lepas field circuit, sistem ni what type of system? Field circuit control DC generator. Betul tak? The first one. Yeah. Okay.
Yeah.
For this part, okay, this is considered combination for the previous subsystem. We already cover armature control DC motor. Lagi apa? Field control DC motor. Another one is a field control DC generator. Okay, we already covered 3 subsystem. 3 system, and then from here, medium combine. Okay, medium combine field control DC generator and armature control DC motor. Okay, I combinekan 2 system jadi the complex system ni. Okay, meaning the first one, this is field control DC generator. Okay, this is your system number 1. The big system number 1. Okay, the second system is the armature control DC motor. Okay, from 1, apa yang you boleh derive? What subsystem from 1? 1 is a field circuit. Betul tak? Okay, the second one, from the armature, you can define your voltage. Voltage apa? Voltage generator. From system number 1. Okay, from number 2, apa yang you boleh derive from number 2? Satu, armature circuit kan? Betul tak? Lepas tu, DC motor. Okay, you have to derive your DC motor. Okay? DC motor, how many equation you boleh derive from the DC motor? Satu is a back EMF. Another one is a torque. Macam tu lah dia punya fishbone dia. Okay? Dia punya sub equation yang you all boleh derive. You all just list saja. You all just cache ataupun just throw you list je lah. Contohnya you listkan, first you define dulu. First you define what is the system from this complete network. Okay, meaning like this. Number 1 is a field control DC generator. The second is a armature control DC motor. Okay, from there you detail through is from equation number 1. So what type of equation yang you boleh derive? Okay, first is a field circuit. The second one, you have to derive the voltage generator. Okay, after that, we go through our system number 2. Armature control DC motor. Okay, you have to derive your armature circuit. Okay, and then you have a DC motor here. So, you have to know DC motor, you can derive 2 equation from that subsystem DC motor. You have to derive the back EMF, another one you have to derive torque. Okay, and then the last one, apa? What's the last one? The last one is a rotational mechanical system. Okay, from here you derive lah apa equation dia. Okay, so how many equation you can derive from this electromechanical system? How many equation?
6.
How? 6. 1, 2, 3, 4, 5, 6. Yes, good. We have 6 equation and supposedly we have 6 functional block diagram. Okay, from 6 functional block diagram, you define or you obtain your overall block diagram to represent the electromechanical system. Okay, cuba buat. Let's try. Madam, give 5 minutes. Boleh? Okay, or after this you try. Okay, we just discuss all the question and after this you do as your homework. Is it okay like this? Boleh tak?
Boleh.
Okay.
Boleh.
So kita discuss dulu the next question. Number Bisa nak buat Alamak, tidak besar ni dia dah jadi lagi. Okay, that's number 2. Number 3. Okay, this is untuk number 2 ya, yang kat atas ni. Yeah, this is actually from equation number 2. Nanti madam share the tutorial dekat WhatsApp. Okay, madam akan share dekat WhatsApp. Okay, then number 2. So let's say we see number 3. Number 3, P control DC motor used to drive initial J1, J2. Okay, from here we have 2 initial. Okay, we have 2 initial. Macam mana nak buat? We have 2 initial here. Okay, so apa yang you all boleh, what system you can list dekat sini? What type of system here? Apa sistem dia? Okay, from here I already give the block. Okay, that's represent to the overall system. Okay, G1. G1 is a transfer function belong to what? Boleh tengok tak daripada sini? G1. G1 is a represent transfer function for which system? G1. I give you VF, I give you V2. So G1 ni represent from which subsystem? Siapa boleh jawab? G1. G1. Yes, good. G1 from amplifier. Okay? And then how about G2? G2 belong to which subsystem? Huh? G2. G2 from which subsystem?
Field circuit.
Yes, good. Field circuit. Okay? And then how about G3? G3? G3 from which system?
Motor.
From which? Yes, good. Very good. Motor. From motor. How about the last block? G4. How about G4? G4 belong to which? Sorry? For rotational mechanical system. Okay, meaning G4 is belong to this. But we have make assumption. Okay, you have to make assumption because here is a output. They choose angular displacement beta kan? Okay, from here output you is a angular displacement beta. Here we have angular alpha and here we have angular beta. We have 2 variable here. Angular displacement alpha, another one is a angular displacement for beta. Okay. So you have to derive meanings from here. you have to derive this one. Okay, for mechanical, for rotational mechanical system. So, okay. So the first one, for mechanical kita buat later. So we complete G1, G2, G3 first. How to derive G1? How to derive G1? G1 is a V out. V out ni sama dengan apa? What's the V out? V out for G1.
BF.
Okay. So meaning VFS equal to KA and multiply with the I2 kan. So jadi, so KA dekat sini, G1 ni adalah KA. Right? Okay, how about G2? G2, how to derive G2? Field circuit. So you have to derive the field circuit. So meaning VFS equal to, they have a resistor inductor, right? So LF, ni ada S So IFS, betul tak? Okay, so you have to rearrange to make it IF if is your output equal to 1 over, okay, and multiply with the VS kan? Okay, this is your gain. Okay, this is your gain number what? Gain number 2 kan? Okay, this is your gain number 2. Okay, how about gain number 3? What equation for gain number 3? Torque proportional with the IF. Okay, so torque equal to Km IF. So here dekat sini adalah Km. Okay, and the last one for mechanical, for rotary mechanical system, how to solve? We have two displacement. Do you remember where is the torque? Torque is somewhere. Your torque is at initial one. So you have to derive equation by, you have to derive initial by initial. Okay, remember the previous slide? How to derive J1? Guys, how to derive J1? J1. How to derive J1? Initial number 1. Initial number 1 is related to alpha, right? J1, which one related to the motion theta alpha? J1 S squared. Apa impedance dia? What's the impedance for initial? J1S. How about impedance for damper?
DS.
S plus K multiply with the, betul tak?
Betul.
Okay, dan minus? Minus with apa?
K alpha B.
Yeah. Minus dengan K1 plus DS alpha theta beta. Betul tak? And then equation ni sama dengan apa? Sama dengan apa? Torque dia dekat mana? Where is our torque? Kita punya torque is a link to theta alpha kan? Link dekat sini kan? Okay, so jadi, Allah Akbar. Sorry. Hilang. Okay, kejap Sekejap. Alamak. Okay. So, okay. So, apa dia? Okay. So, ni sama dengan total of torque. Okay. So, how about initial number 2. J2. How about J2? Macam mana nak check initial number 2? J2 S squared
S square plus
plus K1 plus K2 kan? Betul tak? Plus damper. Betul? Darab dengan theta beta minus
minus
minus apa? Kita minuskan yang ni kan?
A.
Because K1 and damper that one is between alpha and beta. Okay, so kita kena minuskan dia. So minus dengan alamak hijau lah pula. Ya, sekejap. Alamak, sorry. K1 plus damper darab dengan alpha equal
0.
yes, good, equal 0. Because the total applied torque is related to theta alpha. Okay, so we have two equation. So macam mana how we want to derive ataupun macam mana how we want to simplify to get alpha beta. How to get alpha beta here? Alpha beta pula. Theta beta. Because kita punya output adalah dia nak guna ni. Dia nak guna ni as your output. So, what's we going to simplify here? Apa kita nak buat kat sini ni?
Cramer's rule.
Okay, we using Cramer's rule untuk dapatkan T dan alpha beta kan dekat sini ni. Tengok ni. Ni kita nak cari ni. So maksudnya persamaan dekat sini adalah theta beta over sama dengan apa? Betul tak? Okay. So cuba buat dia punya theta, cuba Cramer's rule. Boleh tak buat? Cuba dapatkan equation ni yang madam tulis ni. Try lah. Okay, nanti cuba as your homework. Boleh? Try this question as your homework. Okay. So, ada lagi. Ada masa ada 3 soalan je. Habis dah. Ada 3 je. Tengok, rela lagi dalam dia ni. So we have 3 tutorial. So number 1, we finish. We have 2 and 3 as your exercise. Okay. Boleh cuba tak? So let's try complete this tutorial. Next week we will cover new chapter ya, minggu depan. Next week bila you all punya kelas? Wednesday. Okay. Internet saya tak cantik, madam tak dengar, madam cakap sangkut-sangkut. Orang lain dengar suara madam okay tak? How about the rest? Is it okay?
Okay.
Okay, maksudnya internet Mio, connection Mio ada problem lah tu. Okay. So madam, by next week, Wednesday, I will be cover our new chapter, transient response. Meaning transient response is we analyze the transfer function. Okay, from chapter 1, chapter 2, chapter 3, we learn how to define or how to obtain the transfer function. Okay, so from the next chapter, we will be analyze the transfer function. We want to define whether our system stable, unstable, or marginally stable, and then we want to analyze the behavior of that system. Okay, kita nak define pula dia punya behavior dia. Okay, so for today, I want to stop here. Okay, so I would like to everybody try the